Welcome back everyone. This video is about inline functions in F Sharp. And before we discuss what inline functions are, let's look at a problem statement, a situation that you may encounter. So we have two functions, very simple functions. Let x add, which is two parameter function, does x plus y, and apply, which is again a two parameter function, calls f with x, whatever the return value of fx is becomes the return value of apply. So let's do this. Add 1, 2, and send the output to console. Sorry. And similarly apply some function fun x equals to x times 2, send 2, and let's just run it. So all goes well. Add is working, returning 3 and 4. Apply is calling this lambda with 2, you get 4. Now let's do 1.0 and 2.0. So we should get 3 or 3.0. Let's see. Yeah, 3.0. Okay. So I'll get rid of this for a little while. I'll come back to this. First thing we did was 1.0, 1 and 2, and everything worked well. And then we did this, and it stops working. When I first encountered this, I was heavily confused for two reasons. One, in the world of C#, additions of floats and numbers, they're kind of freely doable. That's not what you can do in F#. But when I did this, everything is working fine. And when I did this, everything was working fine. I was under the impression that x and y are generic parameters. It's rather silly to assume these are generic parameters, because how would compiler know if these are actually generic values? How to do x plus y? Let's force generics here. Let's make it this, of type A, of type B. If that's the case, if that is what is happening, how would the compiler know that x plus y can be done? So if, for example, if you are calling 1.0 and a string, you see you get an error over here. The problem is that when you have an open-ended signature like this, it's not generics. It's actually what I call unresolved, not finalized as of yet. The compiler says, okay, I don't know what to do with this. Type inference makes it, I don't know how to catalog it, how to put it, where to label it, and so on and so forth. The compiler is in wait and watch mode. So the moment this is encountered, the compiler says, okay, you are calling add function with float parameters. So if you look at the signature of this function now, it is float, float, float. If you comment this out and you use this, you will find int, int, int. Similarly, if you do this and you say add 1 and 2, the signature of this function should be string, string, string. In all these cases, addition is possible. So that's what the compiler is doing. The compiler is not resolving anything before it encounters some evidence of its usage, its purpose. And when that is encountered, the type parameters are set. And this is what I have dedicated a section in this article for. Type inference is not generics, not necessarily. In some cases, yes. And this is a good example that no matter what you do, as long as x can be passed to f, you can call any function. For example, apply a function which takes x and does x times 2, and you can pass 2 to it, a function which does this, you can pass 2.0 to it. So you can practically pass anything to this function as long as the input you are sending, the x, can be passed to f. You can pass anything, and if you inspect the signature, it's truly a generic function signature. Okay, a b x a b, and that's what the key thing you have to figure out, realize here is, for compiler it's not always possible to generalize an idea. This cannot be generalized. Now you may wonder, you can call plus function with whole lot of things. How come generics isn't, or type inference is not creating a problem there? And that is because of this bit that you see here, requires member plus, which I've talked about in the later stages of this article, that there are two ways you can handle this. Constraints, which I'm not talking about right now because that in itself is a long and detailed, complicated topic, perhaps for a later session. What I wish to do right now is talk about inline functions. So when you declare a function with let inline binding instead of a let binding, what you're telling the compiler is, wherever add is used, instead of a function call, replace the calling code with the body. So it's just for convenience sake, when you say this, you are effectively saying 1 plus 2. When you are saying this, you are effectively saying 1.0 plus 2.0. And when you are saying this, you are saying 1 plus 2. So when you use inline functions, the generalization of function is no more a problem for the compiler. The compiler says, I'll just replace this with this, and then it is the local site, the calling site's problem. For example, if I say 1, add 1, 2, now it's telling me here that type string does not match the type int, meaning thereby it cannot be added, and so on and so forth. The data types over here are more or less irrelevant. This replaces this by the actual values. So when you are dealing with functions which can be freely generalized like this, there is absolutely no problem. But when you are dealing with functions which cannot be freely generalized, you will have to use inline functions. The other usage of inline functions is to use in the areas where performance is very critical, but that's not the scope of this discussion. So whenever you cannot generalize a function, you better use the inline version of it, because wherever that inline function is called from, the local site will have the body expanded locally, and the types involved there will be used. So that's all for now. I'll see you in the later one. Thank you.